Okay, equations. We talked about the difference between expressions and equations, didn't we? So an expression is just like any, collection of terms, right? Could be a monomial, which is one term. What's a two-term expression called? Binomial. Three-term is called a trinomial, right? Okay. Now, you know what an expression is? What's an equation?
Something with an equal sign?
There's a couple of expressions connected with an equal sign, right? It means one of them equals the other, okay? So know that, because sometimes, especially like on the Regents exam, they will ask you to write an equation for some situation, and kids will write an expression, and you lose points, right? Because they're that picky about it. So know the difference, know which one's which. Or they'll ask you to write an expression, and they'll write an equation, and you'll lose points, okay? All right, just real quick then. Exercise 1. Which one of those is not an equation? Why?
Because it doesn't have an equal sign.
Everything else got equal sign. Easy enough. Good enough. All right. What do they got going on down here? So consider the equation. 2x minus 8 equals 10 minus x. Why can't you determine whether this equation is true or false? I guess just by looking at it. What makes an equation true? Like the variables.
It'll be equal, like, it would be like 2x.
You need to know what? What would you need to know? See if it's true or not, if the two sides are equal. Yeah, you need to know the value, right? So the reason you can't tell whether it's true or false is it will depend on the value of x, okay? It will depend on the value of x. Okay? And then over there in part B, they've given us a potential value for x equals 5. Will the equation be true? How are we going to find out?
We are going to
Plug it in, right? So 2x, so 2 times 5 minus 8 might equal 10 minus 5. So that would be 10 minus 8, which is 2. And does not equal. See the does not equal? Huh? Negative 50? Or 5?
Something.
Shoot, yeah. Okay, yeah. So we would say false here. Okay? Not true. Hmm? What part? That these are not equal? Or where we got these? Okay. You sure you're good? All right, on to 6. C. Show that x equals 6 makes it true. Remember the thing? Yeah, it does. All right. So let's just plug in. What was it? It was 2 times 6 minus 8 might equal, what was it? 10,
Equals
10 minus 6. It's up there. So that's 12 minus 8, which is 4. It does, in fact, equal 4. So true for that particular value of x. Okay. So in order to be a solution to the equation, the value of x you're given or work out must make the equation true. It must make one side the same value as the other side. Hey, it's that laptop. We're doing math, man. Just this. So like the stuff I'm writing up there, right, you should be writing it down. Right? Okay. All right. So, next page. And I'm not going to do all of these things here. So, they want us to determine whether the values for the given variables is a solution to the equation, okay? So we're just going to plug in, okay? I'm going to have you guys do the first 2 here on your own, okay? And you tell me whether it's a solution or not. Plug it in, make it look the way I do, okay? Let's see how you do.
So it's equals 17. It's true.
So it makes it true, right? You plugged in 2 times 7 plus 3 equals 17. 14 plus 3. Yep. So that's true. Just put a C there. Okay? How about for B? Did you get that yet?
It's false. No, I didn't. It's -2 is not equal to -4.
That's true. So if we plug in 10, you'd have 10 minus 20 over 5 equals -4. Right? -10 over 5 equals -4. -2 does not equal -4. So false. Okay? You get the idea. I'm not going to do. Huh?
-2. Yeah, you get -2.
I'm stupid. -10.
Tegan, you are not stupid. Don't say that about yourself, girly.
Really?
But now she's really confused. She honestly thought she was stupid, and now you're actually telling her she's wrong. Now she's going to feel horrible that she's wrong.
You're stupid.
Okay. All right, we're going to skip the rest of the. You get the idea, right? Everybody gets this? Or skip that. And hey, by the way, yeah, we're going to skip this.
Her.
Did you say
So,
her?
so all of this, you see, I don't plan on doing this recording ever again for this particular section of this class, so all of this is going to be for eternity. Students, your children will hear that. Okay? All right. So I do want to give you a quick note on something, because there's a couple of Regents questions that are like this, but there's just a little twist to them.
Dude, what are you talking about?
I said it sounded like you said occur. I was like,
Solutions in X, comma, Y form, right? You're familiar with these ordered pairs like this, right? Like when you're plotting points, ordered pairs to plot points in the graph, probably, right? Okay? So you might see a question that looks like this. Is 5, comma 9 a solution to y equals x plus 4? And how would you figure that out? Well, remember this 5, comma 9 is actually an x, comma y, isn't it? And do you see an x and y in the equation?
Yeah.
So what would you do to find out? Replace the y with a what? And the x with a, right, so let's see, y 9 equals 5 plus 4, so yeah, it does. Okay? They didn't include like an ordered pair format in the notes. I want to give that to you, okay? And now we'll flip over to the Regents questions. And they're going to ask it kind of that way. All right? Page 81. Which pair of equations from those 4 choices down there would have -1, comma 2 as a solution? Remember, this is an x, comma y. So you might have to try a couple. I mean, this is the type of math Regents question I absolutely abhor, because it's guess and check. It's like plug, so you just got to plug it in and see. All right?
hate, right?
Hmm?
That means like hate.
Abhor means really hate. Yes, yes.
Because like adore.
It would be the opposite. Yes.
But y equals 2x.
So you just gotta plug in, try this, try that one, then try the next one down or whatever. 1. Well, let's see. The y would be replaced with a what? A 2, and the x would be replaced with a -1. What's -1 plus 3? Hmm? Okay. So yeah, I get this kind of, so 2 equals 2. Now what about, now by the way, that says and.
Yeah, that's why I don't.
Okay, so if it's and, versus say or, what do you think? It has to make either of them true or both of them? If it says and, they's got to make them both true. Right? With me on that? What's that?
That's harder. I don't understand that.
Yeah, harder. Well, let's plug it into the other one and see.
Are we plugging in like? Oh, I think I understand. So then,
So this one works, right? But since it's and, this has to work for both of them.
are we plugging in the ordered pairs?
Yeah. X and Y, wherever you have an X, right? Yeah. So for the Y here, 2
No, one's not.
equals 2 to the negative 1. You guys, we haven't done negative exponents yet.
No.
But 2 to the negative 1 actually equals 1/2. And 2 does not equal 1/2. Okay? So it's not 1. So try this one here.
Oh my god, this is eraser.
It's negative 1 squared. Squaring means to multiply it by itself. What's negative 1 squared? Positive 1. What? Plus 4 minus 2. That's 5 minus 2, which is
How's that plus 4? That's negative 3.
plus 3. Where'd you get a plus 4? There's no plus 4 up there. Did you see a plus 4?
It's
You're
on,
the only one.
you're on 2, right?
You're the only one, son.
No, he's on 3.
That's 4 minus 2. That's 2. So it makes this one true. What about this one? Negative 4 plus 6, right? It made them both true, right? Right? Because it's an and. If it had said or, I mean, this one up here could have been the solution, right? If it said or, but it says and, so they both have to be true. Any questions on the first one? Hmm. Sometimes it's nice to they'll be the first or second one you try will be the right one on the end, and then sometimes it's like you get through the fourth one. That's why I hate these. It's not even anyway. But they're on the Regent, so you got to see them. All right, let's try number 2. Which point is there a key word in here? Not. Not. In the solution set of that mess over there. So you have to kind of try them out. Go ahead. Give them a try. I forgot to record all that, but anyway. All right. Anybody have any questions on what makes your equations true? The difference between and or, by the way, because we'll run into that when we get into inequalities more. All right?
Oh my god.
Okay. Let me